Welcome to Ask and Learn.
All right. For this problem, uh, we have three paths. So for the path ACB, we know the heat is 90 joules, and we know the work done by the system is 60 joules. So according to the first thermal law, which is W equal to Q minus delta U. So W is 60 joules and Q is 90 joules. So we obtain delta U equal to Q minus W, which is 30 joules. This delta U is the change in internal energy from A to B. So let me see. So for part A, we want to figure out the heat flow into the system along the path ADB, okay, along this one. Although the path is different from the ACB, but the change in internal energy is same for these two paths, okay. So for this path, for the ADB path, uh, we also have the first thermal law, but the work, this is okay. Let's see. This is the work ADB equal to Q ADB minus delta U. This delta U is the same as this one. Okay. So the work done by the system is 15 joules. So we obtain 15 equal to Q ADB. I just use Q here for short. Minus, this is not delta U anymore. This is 30 joules. So we obtain Q equal to 45 joules. Okay. For part B, so the system is returned from B to A, along the curved path, along this one. Okay. And we know the absolute value of the work done by the system is 35 joules. So we want to know if the system absorbs or liberate heat. We can see that from B to A, the direction is pointing to the left. So the work done by the system is negative value. Okay. So work in this case is negative 35 joules. This is negative. All right. And according to the first thermal law, this will be BA. BA equal to QBA minus delta U BA. All right. So this delta U BA is opposite to this delta U because this delta U represent the changing represent the internal energy difference from A to B, but this delta UBA is the internal energy difference from B to A. So these two values are opposite. So this delta UBA is negative 30 joules. Then we obtain QBA equal to, so WBA is negative 35 joules and plus delta UBA. Delta UBA is negative 30 joules, so minus 30. So the result is negative 65 joules. And we obtain this negative value. So a negative heat means that the heat is flowing out of the system. So which means the system is liberate heating. It is liberate heat, and the amount of heat is 65 joules. So it is liberate heat. And for part C, we have UA equals 0, UD equals 8. So this is 0, this is 8. So we want to find out the heat absorbed in the processes AD and DB. Okay, so for the process AD, again we can use the first thermal law. we can see that the heat flowing to the system along the path AdB is 15 joules, right? And in the process dB, the work is 0 because the volume does not change. So all the work done by the system is in the process AD. So work AD in this case equal to 15 joules. 15 joules. And work dB 0. All right. So according to the first thermal law, the work AD equal to the heat flowing to the system in process AD minus the change in internal energy from A to D. D is 8, A is 0. So the change in internal energy in the process AD is 8 joules. And this WAD is 15 joules. So QAD is easy. It's 23 joules. All right, just move this 8 to the left-hand side. And the heat in the process dB, we can use the first thermal law in this process. So W dB equal to Q dB minus W dB. All right. So this is 0 according to this one. This is 0, and the Q dB is the one that we need to find out. So we also need to know this W dB. To figure out this W dB, we need to utilize this one, this W, because W is changing internal energy from A to B. Okay, from A to B. So W equal to W AD plus W dB. All right. So WAD WAD is 8 joules. WDB is the unknown variable, and W is 30 joules. So WDB is 22 joules. Then let's go back to this relation. WDB is 0, WDB is 22 joules, so QDB is 22 joules. Equal to 22 joules. All right. So this is the QDB, and this is the QAB. All right. Yeah, that's it.